This is the paired sample t-test video. A little background on the paired sample t-test. The standard formula for calculation of t assumes that there is no correlation between the groups. This is a test where we're testing a group of participants twice in a pre and a post-test comparison. The pre-test, you give the pre-test, you do an intervention, and then there's a post-test. Or it could just be a pre and then later on do a post-test. There's lots of ways of doing it. Definition. The paired sample t-test assumes a relationship for the correlation exists between the scores of the person's score on a post-test is partially dependent on his or her pre-test scores. So be it that they are related, they're not unrelated, they're related. So like mile time to mile time or mass score to mass score. Let's see, anything. In this case, we're going to be looking at caffeine and no caffeine. In this example, we're examining the hours slept in caffeine. The test is performed on 10 participants where one group drinks caffeine and the other one does not. And as the keys are hour slept, caffeine, and no caffeine. So if you see the data right here, condition 1 is caffeine, condition 2 is no caffeine. There are 5 participants, and as you can go through the numbers here, you can actually, because there's only 5 participants, you can see that there is a complete disparity between the two. The people that drank caffeine, their numbers were lower. Okay, in the paired sample t-test results. First thing we're going to look at is we're going to look at the paired sample results. Once you've run the test, this is what the output looks like. This is one portion of the output. You'll see that the caffeine and no caffeine are here. In this one, in the paired sample, it does not give the dependent variable, which is hours slept. So caffeine and no caffeine are two of the variables. The third variable is what it's being run against, which is the dependent variable of hours slept. Okay, so these are the means. The n is for the number of participants, and the standard deviation tells us the dispersion from the mean. Okay, so when we get to the point of drawing conclusions, we are actually looking at the difference in the means. So I use this example because there's a good disparity between the two and the numbers are a little bit different. So 9.20 for no caffeine and 5.40 for caffeine. So we can immediately draw a relative conclusion of what? That the participants who drank no caffeine had more hours slept than those that drank caffeine. The next portion of it is correlation. Now, some of you have done the correlation week and some of you have not, so I'm just going to give a quick synopsis and what you need for your paired sample t-test. We're measuring the relationship, in this case, caffeine and no caffeine. Okay, we're going to take a quick look at scatter plots and the Pearson correlation coefficient. Okay, so what is a correlation? It's a way of measuring the extent to which two variables are related. It measures the pattern of responses across variables. Measuring relationships. We need to see whether one variable increases, the other increases, decreases, or stays the same. This can be done by calculating the covariance. We look at how much each score deviates from the mean. If both variables deviate from the mean the same amount, they are likely to be related. In this case, we're going to be reporting direction and strength. Direction will either be positive or negative. The strength is either going to be slight, moderate, or high. And when the correlation number is being shown, it's 0.03, 0 to 0, 0.000 to 0.03 is slight, 0.05 is moderate, and 0.07 is strong. This is a scatter plot. This is a very small relationship or no relationship. Your number would basically be 0, 0, 0, or it could be 0.001. It's going to be very close to 0, and we'll go over that in a few minutes. This scatter plot shows us a positive relationship, okay? And if I use this appreciation of Dimmu-Borgir and age, okay, if I am using this line that's going up, you'll see at right here, the first one is at 10 and 20. As they get older, at the age of 70, whatever this is, has gone higher. So in a positive relationship, both scores go up. So it's as age increased, appreciation of Dimmu-Borgir increased. A negative relationship, on the other hand, is when it goes down. So as you can see how age goes up, the appreciation for Dimmu-Borgir goes down. So you can see here, at the very end of this, 20 here or below, almost to 0, gives the higher ages. In a negative relationship, one set of scores goes up and one set of scores goes down. So as age goes down, appreciation of Dimmu-Borgir goes down. Negative relationship, both go down. Positive relationship, one goes up and one goes down. I'm going to use a correlation example here. Sorry, let me go back. I'm going to use a correlation example to understand what a correlation matrix looks like. Either again or if this is the first time. You can see that exam performance. Oops, darn. Exam performance and exam performance are equal, so they're going to come up with a perfect score of 1. Here we're looking at performance and exam anxiety. It's a negative correlation at 441, so it's pretty much still a slight correlation, okay? And then over here, time revising and exam performance. Now that would be more of a slight positive correlation. This would be negative, and how you know it's negative, there's a negative sign. Over here, there's a positive sign. So negative correlation, positive correlation. Okay? Again, here it is in a little better table. So in this case, exam performance and exam anxiety was at a negative 4.4. Okay? All right? So let's look at our correlation for the caffeine and no caffeine. I have changed the numbers from the example video to give you a greater vision of it, because the other one puts you real close to being no correlation. Okay, the Pearson moment correlation is slightly negative correlation at -2. R equals negative 2.35 and is non-significant at above 0.05. So we have 5 participants and we don't have to worry about this. This is the number. This is the R value. This is your correlation number. And you see it here on this number line down here. If this was positive 0.235, it means the same thing. It just means direction. So if we go back to earlier, in this case, we can automatically say if it's negative, okay, one goes up and one goes down. That's why it's negative. If it was on 0.235, both scores were going up. So in this case, we know as one score goes up, the other one goes down. We're not running the actual scatter plot to find that out here. Okay, and then you have a 0.70 over here for your significance. So what we're looking at here is the part 3. This is the paired sample t-test. First off, this right here is the mean, okay? And that's the mean difference between the two means we saw earlier in the video, okay? Here's your t-value, your df, and your significance level. This one is below 0.05, so it will be reported as p is less than 0.05. If I was to go back to your correlations, you must report this correlation when you report your correlation, which can be different than the one on this slide. So you may have in your correlation it may be significant, and here it is non-significant. I don't know until you run your data.